In previous problems, we've gone from the absolute value to the number line, and in math we need to know how to go forwards and backwards. So in this one we're going to look at the number line and see if we can figure out what the absolute value is. So we know that the absolute value is the measure of distance from some given point. So when we look at this, we can see that we have a center of 5. This is a center because this is a distance of 2 away, and this is also a distance of 2 away. So I know that my distance is 2, and I know that 5 is my center. So let's start with that. I know that my center is 5, so I have my absolute value is going to be x minus 5, because remember it's always the opposite of what we see here is what goes in here, and the other way around. And that has to have some sort of distance of 2. So I'm going to have some sort of inequality right here. I need to figure out what that is. So this distance is 2, but going out here, if I'm out here, my distance is getting bigger. So my distance becomes greater than 2. And same here, my distance becomes greater than 2. So my absolute value has to be greater than 2. No equal sign because I don't have any of the holes filled in. So that was the end of that problem. So that's going from a graph. How about going from a compound inequality? So if we look here at this example, this is a compound inequality. So it's hard for me to go from here to an absolute value without looking at it on a number line. So I'm going to translate this to a number line because it just makes things clearer to see a picture. So I know that I have 0 on one end and I have 3 on the other. So it's 1, 2, 3. So I have to find the halfway point. What's the halfway distance between 0 and 3? Well, that's going to be 3 divided by 2. And 3 divided by 2, you could say, is 1.5 if you wanted to. So 1.5. So I know that the halfway point is going to be a distance of 1.5 from here and 1.5 from here, which happens to also be 1.5, or if you want to say 3.2 is the middle. So that's my center. Either number, they're equivalent, so it doesn't really matter. Okay? So that means also, let's look at the inequalities before I get ahead of myself. So x has to be less than 3, but x also has to be greater than 0. So x lives right here. I just want to point out how this lines up. The 3 is over the 3 on my number line. The x is straddling over this line segment, and the 0 is over the 0 on the number line. Okay, so now we know from absolute value that it's the distance from center. So we have x. This is positive, so I'm going to make it negative. I'm going to use -3/2. And my distance is what? My distance also happens to be 1.5. Okay, it just so happens it's also 1.5. So I'm going to put 3/2 here just to be consistent. Now, if I'm going this way, is my distance getting smaller? It's getting closer. It's getting smaller to my middle point. As I'm going this way, my distance is getting smaller. It's getting smaller to my center point. That means that my absolute value wants to be less than this given distance. So that's the end of solving that particular type of problem. Let's do one more. Compound inequality. Compound usually means 2. but it can mean more than 2. It can just mean a couple things put together. So once again, what do you think I'm going to do? I'm going to draw a number line because I just can't figure this out any other way. I have to see it. Once I see it, then I can figure out what's going on. So here I have -1, so I'll put -1 right here, and I have 3. So it's very important that you, when you do the number line like this, that you just don't randomly place it. So this is 0, 1, 2, 3. Okay, so I want the halfway point between -1 and 3. Well, this distance between -1 and 3 is 4, isn't it? 1, 2, 3, 4. And half of 4 would be 2. So if I go in 2 on this side and in 2 on this side, I get the middle. Okay? But don't confuse that number with what the value is at this place. This is just a distance of 2 in on both sides. I said distance, didn't I? So this is my distance of 2. This is my distance of 2. They're equal. So this value right here is 1. Because 1 plus 2 is 3. 1 minus 2 is -1. Okay, I kind of did it again. I got ahead of myself. And so I need to go ahead and draw in where my values of x live. So here x is greater than 3. So I'm going to be at 3. I'm not going to color it in because it cannot equal 3. It just comes really close to 3. So x is greater. Which way is greater? Well, this goes 3. The next one would be 4, 5. So these numbers over here are all greater. Now I'm going to look at this side. X is less than -1. So this is -1, this is 0. Well, 0 is bigger. So let's go the other way. This is -1, this is -2. So it must go the other way. X is less than -1. Okay, so that's what my graph looks like. So let's do my absolute value. Remember, my center, that's my center. And this here, this 2, is my distance. Okay, so my distance from 1 of 2, if I go 2 away from 1, I end up at 3. If I move a distance of 2 away from 1 in the other direction, I get -1. So that means I have x. This 1 is positive, so I'm going to put -1. And then I have a distance of 2. So what's my inequality going to be? Well, my absolute value must be greater because my distance out here is bigger than 2 away. This would be 3 away and 4 away and 5 away, and the same thing over here. So my absolute value here has to be greater than 2.